Okay, welcome back to Level Chemistry. Today we're going to have a look at acyl chlorides, their functional groups and the naming of them. Okay, so first of all, the general formula for an acyl chloride is RCOCl. Okay, so your functional group for the acyl chloride, you're looking for this COCl group. Okay, and in one of those, in an acyl chloride compound, your first carbon when it comes to naming is this carbon here that's attached to the functional group, so it's following the same general rules. Okay, so we start numbering at the functional group. Okay, so when it comes to naming the acyl chloride, we start counting the number of carbons in the carbon chain at the carbon of the COCl group. Okay, so here I've got methanol chloride, meth, one carbon, so it's meth. I've got the COCl group, so it's an acyl chloride. Okay, and that is carbon number 1 because it's the first carbon in the chain, so it's methanol chloride. This one here, I've got 2 carbon atoms in my chain, so meth, eth, that's ethanol chloride. COCl makes it an acyl chloride, so ethanol chloride. And then following the pattern, I've got meth, eth, prop. I've got propanol chloride there. COCl being the functional group of my acyl chloride, and I've got 1, 2, 3 carbons in my carbon chain. Okay, right, so now let's understand then the electron displacement across the acyl chloride group, and this will help us to understand why acyl chlorides are so reactive. Okay, so let's have a look at ethanol chloride, for example, to start with. Okay, so here I've got my acyl chloride group, my COCl group, and you'll notice that attached to this carbon I've got an oxygen. Now we know from previous work that oxygen is really quite a strongly electronegative atom, so that means that the oxygen withdraws electron density from this covalent double bond, doesn't it, quite strongly. Okay, so that means that electron displacement across this carbonyl group takes place, and the electrons get drawn towards the oxygen there, leaving the carbon here, making this carbon delta positive relative to that oxygen, which becomes delta negative. Okay, now also in this group we've got chlorine. Now chlorine is quite a strongly electronegative atom. Okay, so that also withdraws electron density from the covalent bond between the carbon and the chlorine. So if you think about it, we've not only got the oxygen here pulling electron density away from that carbon, we've also got this chlorine pulling electron density away from that carbon. Okay, so we've got 2 electronegative atoms attached to that carbon, withdrawing electron density from the bonds that attach them to the carbon, therefore making this carbon really quite delta positive. You know, I could almost, just to emphasize what the point I'm making, I could draw a bigger delta positive there, couldn't I? Delta positive, yeah, that's really delta positive there because it's being influenced by that atom and that atom withdrawing electron density away from it. Okay, so this is quite a standard exam question really. You need to be able to understand why acyl chlorides are more reactive than their equivalent carboxylic acids. Okay, so this enables us to understand the reasons why ethanol chloride is more reactive than its equivalent carboxylic acid. Okay, so that carbon there, the electrons around that carbon are being withdrawn or pulled away by that oxygen and that chlorine, making that really quite delta positive. Okay, in the equivalent carboxylic acid, that carbon is attached to an oxygen, so that's the same effect as there, but this time here, instead of having the chlorine atom, we've got the OH group. Okay, and the OH group doesn't withdraw electron density from that carbon as strongly as the Cl does. Okay, so the Cl withdraws electron density more strongly than the OH group. Okay, making that carbon more delta positive. So therefore nucleophiles, okay, they're species that like positive charge, are much more likely to attack and react with the delta positive carbon of the acyl chloride than they are with the carbon of the carbonyl group, the C equals O group, in the equivalent carboxylic acid. Okay, Now, as we move on through this topic, you'll see there's actually a clear distinction in this reactivity. Okay, so in fact a clear distinction can be drawn between the reactivity of acyl chlorides and carboxylic acids, as acyl chlorides go through nucleophilic addition-elimination reactions, whereas the equivalent carboxylic acids do not. Okay, and that's something that we'll be coming on to very soon. Okay, I hope that's been helpful today, and that's everything for today. Thank you for watching, and don't forget to like and subscribe and click on the bell notification to stay fully updated.